Hello friends, welcome to Vitplum. Today we are going to discuss about mechanical rotational system. I have already discussed about mechanical translational system. You can check out in the description box that I have provided you with the links. So let us solve a problem on mechanical rotational system. So here he is asking us to write the differential equation governing the mechanical system shown in figure and obtain the transfer function of the system. So here this is the given system where J1 and J2 are the moment of inertias and K is the spring, B is the dashpot that you already know. So let us solve this problem. So first consider the moment of inertia J1. So here it is the free body diagram of the moment of inertia J1. Here you have, right? So this is the moment of inertia diagram where T is the torque which is acting only on the J1, right? And theta 1 is the variable. In mechanical translational system we have seen the variables as x, right? Here we are assuming as theta variable. Now apply Newton's second law. What is Newton's second law? T equals to Tj1 plus Tk. The Newton's law states that the sum of the applied forces is equals to the sum of the opposing forces on the particular body. Let me explain you the terms first, then later we will solve the problem. So in mechanical rotational system we have three components: moment of inertia, spring, dashpot. Firstly, moment of inertia. The opposing torque due to moment of inertia is proportional to the angular acceleration. So this is the diagrammatical representation of the moment of inertia, where T is the torque and theta is the angular acceleration in the case of moment of inertia. And again in the spring case, the theta will be different, like it will be angular displacement. In dashpot it will be angular velocity. And the equation is given as T equals to Tj, and that is given as in differential equation form. It is given as J d square theta by dt square. And second term is spring. The opposite torque is proportional to the angular displacement. Okay, this is the spring. Okay, and T is the torque, theta is the angular acceleration, where the equation is given as T equals to Tk. In terms of differential equation, T equals to K theta. And the third term is dashpot, where in dashpot the opposite torque is proportional to the differential angular velocity. So it is the diagrammatical representation of the dashpot, where the equation is given as T equals to Tb, where Tb is b into d theta by dt. Now let us solve the problem. Now write the differential form for this equation. T equals to Tj1, I have already told you that is J d square theta by dt square, right? So it is J1 because the variable is J1. Okay, J1 because we are considering moment of inertia 1. J1 d square theta 1 by dt square plus K, I said spring, T equals to K theta. But here we are writing K into theta 1 minus theta, because here spring is in between J1 and J2. As we discussed earlier, when the spring is situated between two systems, then we have to consider with respect to the system that we are solving right now. So Here it is the equation that we got. So let us assume this as our equation 1. Now consider the moment of inertia 2. So this is the free body diagram of the moment of inertia 2. Here we don't have any torque because torque is acting upon only moment of inertia J1. So we are writing torque equals to 0 on the moment of inertia 2. And theta is the variable. These are the terms related to our moment of inertia 2. Now let us apply Newton's second law. Apply Newton's second law. Now the torque balance equation is T equals to 0 in our case now. So 0 equals to, I am writing directly, 0 equals to Tj2 plus Tk plus Tb. Now write these terms in the differential equation terms. 0 equals to J2 d square theta by dt square plus k into theta minus theta 1 plus d into d theta by dt. Let us assume this as our equation number 2. Now what is the next step? Step 2 is apply Laplace transform for equation 1 and as well as equation 2 also. Let me write the equation 1 again. T equals to J1 dt square theta 1 by dt square plus k into theta 1 minus theta. This is the equation 1. So now we have to write the Laplace transform for this equation. What we get? T is T of s equals to, for this term we have J1 s square theta 1 of s plus k into theta 1 of s minus theta of s. When we are taking theta 1 as common from these two terms, then we get theta 1 of s into J1 s square plus k minus k theta of s. Let us assume this as our equation number 3. Now we have to write the Laplace transform for this equation number 2 also. What we get? Here t equals to 0. We need not to write t of s here. So 0 equals to J2 s square theta of s plus k into theta of s minus theta 1 of s plus b into s theta of s. When we are taking theta of s common from these three terms, then we get theta of s into J2 s square plus bs plus k equals to k theta 1 of s. So let us assume this as our equation number 4. Everybody knows that the transfer function is given as Laplace transform of output by Laplace transform of input. That is, in our problem we have theta of s by t of s. From this fourth equation, I am just writing theta 1 of s equals to, I am sending this to here, then it will become theta of s into J2 s square plus bs plus k by k. Let me assume this as our equation number 5. Now substitute this equation number 5 in the equation of 3. Then we get T of s equals to, in place of theta 1 of s, you have to write this equation. Then what we get? Theta of s into j2 s square plus bs plus k into j1 s square plus k whole by k minus k theta of s. I did nothing, I have just submitted this equation number 5 in equation number 3. That's all. Now after taking LCM, I am taking theta of s as common from these two terms. Then I get theta of s j1 s square plus k into j2 s square plus bs plus k minus k square, because when we are taking LCM of these two, it will become k square, right, by k. Now it is the time to find the transfer function of the given system. Already we know that the equation is this, theta of s by t of s. We already have here theta of s, here t of s. Just let me inverse it, then I'll get this equation. Let me write the transfer function directly. Transfer function first theta of s by t of s equals to, I have to invert because I am taking this to left hand side, then it will get reversed because it has to come in the numerator, right? Then I'll get k by j1 s square plus k into j2 s square plus bs plus k minus k square. So it is the required transfer function of the given system. If you are having any doubts, please comment in the comment section so that I'll address all your comments. Thank you. Please subscribe to Bitplum.